Okay, hopefully the sound won't cut out this time. This is the bicycle problem from your homework, and this is just different numbers than what you are doing in the homework. So all the steps are the same, but you just have to change the numbers. So the problem is given. You have a bicycle, and I'm going to label, this is your pedal wheel. So you pedal on circle A, and it transfers there's this chain, okay, that ensures that this chain is going along the outside of this circle A at the same rate as it's going around the outside of circle B, and then circle C is the drive wheel. Okay, so we need a couple pieces of information. We need to know 1.3 revolutions per second, which is a different value in your homework. We know that this here is 3 inches, is radius on that circle. This circle has radius 2 inches, and circle C has radius 12 inches. So now we have enough information to answer the question. We want the speed in miles per hour. Okay, so this splits up into essentially 2 problems. There's the circle problem, where you try to figure out how fast that outside drive wheel is turning, and then the second problem is to convert the units. So you can think of it as 2 separate academic exercises, but they're in one problem. Okay, so the series of questions you ask are going to be the same. First of all, you need a little bit of insight. You have to make mental note that the angular speed for circles B and C are equal, right? It has to be the case because it's on the same circle. And you have to know that the speed of outside circumference on circles A and B are equal. So there's 2 different kinds of equalities. We're saying in the case of circle B and C, the angles are going around at the same rate, which means they're going to be drawing out a different amount of length, right? Because the big circle is going to be drawing out more length than the small circle. Whereas between circle B and C, there's a different kind of connection. They're connecting, the actual arc lengths are going at the same rate. We also have to use this formula, arc length is equal to radius times theta, and it also, in these problems, we're thinking arc length per second is theta, is r times theta per second, but it's the same formula whether you use the per second on it or not. It's really, at its heart, it's the same formula. Okay, so the first question we want to ask is, what's the angles per second in circle A? Okay, and remember, this formula has to be in radians only. Okay, you can do this whole problem in degrees, radians, or any units you like, but if we're going to just be consistent with the formulas in the book, it's cleaner to just go ahead and use radians. So its angles per second in circle A is going to be what? It's going to be, we're looking for this guy, so arc length, so we're going to use that later. We're going to use that in this formula. We're not going to use the formula right away. We're just going to calculate this outright. Angles per second. The problem is we have it in revolutions per second. So the first thing we need to do is convert revolutions per second into angles per second. So if it's 1.3 revolutions, and a revolution is 2 pi, is the answer to this part of the question. Okay, the second question you ask is, what's the arc length in circle A per second? So in other words, we've now converted revolutions into radians. We're going to now convert these radians into this radial speed, into an arc length speed. That arc length speed is going to get transferred over to this other circle, and finally we're going to transfer that over to the big circle. So arc length in A per second is, what we're doing is taking this formula We're just using it. So we just replace it. What is R? What is angles per second? So we just take this angles per second. And this goes right here. Wink. Okay, so we have that piece. And then this radius in circle A is right over here. You see, I can do this on a computer. I can't do this in class. So I'm literally just dumping these two pieces together. That's all I did. Okay, so that's the arc length per second in angle A. Then I want to know arc length in B per second. But we said the arc lengths are matched. I'm sorry, the arc lengths are matched in A and B. So we just go ahead and grab this answer right up above. There we go. Okay, now, question 4 that we need to ask. Angular speed in circle B and circle C, we get it for free because they're equal. So rather than splitting it into 2 questions, we can go ahead and just make it 1 question. Okay, so what do we need to know? We need to know the angular speed, so this is the piece we're looking for, right? But we already have arc length per second, so we're just going to grab this. So this is going to go right here. Dink. Right, and what we have is we want to dump R in here for circle B. R for circle B is 2. And then we get to cross off these 2's. And so theta per second is equal to 3 times 1.3 times pi. All right, we have another question. Next question is arc length per second. Arc length per second in circle C. And then again, we just take this formula again. And we already had the angular speed. It's right here. And what's the new radius? It's 12, right? Now we basically have it. We just have to review it. So the next thing we have to do is convert it into miles per hour. So this turns into a whole different question. So I'm going to just take it onto another page. Okay, so we have arc length per second, and question 6 is, I'm just using those numbers. Okay, convert to miles per hour. So we have arc length is in inches per second, so 12 times 3 times 1.3 times pi, and this is in inches per second. So how do we convert into miles per hour? Well, we have to do a series of swaps. So one swap, we always have to do a swap where the numerator equals the denominator. So for example, if I say 1 foot equals 12 inches, I can put 1 foot over 12 inches, or I can put 12 inches over 1 foot. But the whole point is I want to make sure I can cancel the units. So that's how you know which order to put them in. It has to match. It does no good to put inches per foot and multiply that in. That doesn't do us anything. Okay, so we could do converting feet and miles, because we can put 1 foot down here. But I mean, 1 foot I'd be converting back to inches. So actually I need to put 5280 feet versus 1 mile. There we go. And that gets rid of the feet and it leaves the miles. And what about seconds and hours and stuff? So we have 60 seconds per minute, and then that crosses off the seconds, and then we want, I'm running out of space here, times 60 minutes per hour. Okay, now what we're left with is the only units we're left with is miles per hour. All the other units canceled out. And so you type that in, and you should practice typing this into your calculator and make sure you get 8.35 miles per hour. Your number will be different, obviously. I just want to make a note about this because we have divide by 12 and divide by whatever. So I'm assuming you can go 12 times 3 times 1.3. If you can't find pi on your calculator, 3.14159 is great. And then here's the thing. Are you going to do times or divide by? The way you key this into your calculator is you say divide by 12. And you'd say, yeah, of course that is. But now what do I do? There's another divide by. Well, you just go divide by 5280. And then you say times 60 times 60. And that's the correct way to key that into your calculator, and you should get the right answer.